Hi everyone, my name is Brianna Fisher. I'm on the Solutions Marketing team here at Veritas.
And I'm Joe D'Angelo. I'm the National Practice Lead for Availability Solutions at Veritas.
Today we're going to be focusing on InfoScale and VMware specifically. So Joe, before we dive into the demo piece, for those who aren't intimately familiar with InfoScale as a product here at Veritas, can you give me the quick 30-second, why is it important, why are we focusing on it?
Sure. So InfoScale is a sort of a suite of technology. It's designed to provide resiliency, storage optimization, and agility for the most critical workloads that you can run.
All right, Joe, let's get into the demo. Talk to me a little bit about the environment that we're looking at.
Sure thing, Brianna. So what we have here is the dashboard for InfoScale Operations Manager. Now, what InfoScale Operations Manager does is it converges all of the operations specifically for storage, availability, as well as reporting for all the InfoScale environments. So I'm going to go ahead and click on the availability card, and as that's loading, what it's going to do is it's going to render all of the different elements inside of an InfoScale configuration that you would want to, take action upon, whether it's configuring different applications that you're going to monitor and protect, as well as organizing them in different what we call groupings or sort of business organizations. In this case, what we've got here is a collection of clusters that have all been registered inside of the dashboard, but the one that we're going to be focusing on for this demo is this Linux cluster here.
Awesome.
It's a 2-node cluster. It's utilizing what we call a cluster file system or flexible storage sharing, a feature of that, as well as this concept we call fast failover. So being able to monitor the sort of the state change information about an application very quickly. Now, in this example, we're using Oracle as that application, but you can replace that with just about any application you'd like. We have a catalog of agents that monitor any number of different off-the-shelf as well as homegrown services.
Sounds good.
So go ahead and expand that. We can click on this Oracle service group here, and we click on this tab called Resource Dependencies. Now, anyone who isn't familiar with this dashboard view, what you have here is sort of a relationship map between all the different components that Oracle needs in order for it to become online. So at any given time, any one of these objects or resources are being monitored. Should any one of them fault for whatever particular reason, the cluster will then immediately move this application over to the other node.
Awesome.
Now, to compare this, because we're talking about VMware and our ability to sort of protect those applications, we also have configured in this environment is a standalone database. Now that's one that's kind of all by himself. He's just sitting on a Linux. Yeah, it's kind of frightening.
That sounds dangerous,
It's
Joe.
very dangerous. It's flying without a net, or I should say jumping without a net. Now that's not to say a customer would ever actually do that, but it's there to sort of simulate this notion that if you're not protecting the applications inside of those VMs, those constituency or those constituent services, then no amount of capability that VMware provides is going to be able to solve that problem.
So before we dive into this, you mentioned flexible storage sharing. Can you double click into that for a second?
Sure, that's actually a really cool technology. Flexible storage sharing is sort of the evolution of our cluster file system, where instead of having to have shared storage, meaning something that exists out on your SAN or some sort of shared direct attached device, you now can use localized devices and actually mirror those between nodes within a cluster.
Awesome.
And this has a lot of different use cases. It helps us address some of the challenges with utilizing the multi-writer flag and some of the restrictions you get with VMware, as well as the cloud. When we start talking about use cases there, FSS really starts to shine.
Awesome. All right, what are you going to show me first?
So I'm actually going to go ahead and simulate the fault of an application. In this case, simulate the fault of an Oracle database. And the quickest way to do that really is, without getting into any real serious detail here, is to go ahead and to just log into the database itself. And from there, I can connect to the database, connect/as/dba. And I can do a select star from the database. And you can see that the database is up and running. This is just your typical output from an empty database. So I'm going to go ahead and exit out of this, exit out of the Oracle user context, and just do a quick grep on the Pmon service is one of the Oracle services that run. And the easiest way to test the failover is to go ahead and kill that service. So I'm just going to do a kill-9 on that particular service, and you can see it's this guy right here, this 2.1. Go ahead.
So this could be planned downtime, or this could be unplanned downtime.
Absolutely.
So in the event of unplanned downtime, how often are applications actually failing? Why are they failing? Can you talk about that a little bit?
So there's a myriad of reasons why an application could fault, right? And as we watch here in the background what's going on, it'll detect, you see I would say that took about 5 seconds,
Yep.
and it detected the fault. So there's a number of things that can cause downtime. There can be something localized to the database itself. If somebody accidentally turns it off or shuts it down inadvertently,
Yep.
you could lose the storage resources. Somebody on
Absolutely.
the storage array could pull a LUN or remove a VMDK in the case of VMware, an IP address, a virtual IP. You could a number of things can cause something that unfortunately none of the VMware features really are monitoring or giving you any sort of insulation from.
VMware is monitoring
The infrastructure,
not application level.
Right?
Yep.
I think that should be our mantra. Applications, not infrastructure.
Absolutely.
Right? Because at the end of the day, customers care about their apps. A
Absolutely.
virtual machine is sort of this ambiguous thing, but the application, that's really what's critical.
Yep.
As well as a lot of other applications that work with that one. And some of the other things that we can do to kind of differentiate ourselves is how those relationships occur.
So we've detected the fault.
Detect the fault already.
What's going
In
on
fact,
now?
it's already failed over the application.
Okay.
So we can go ahead and we can see here now that the fault occurred and that it's bringing up the services.
All right, Joe, so within about 5 seconds, InfoScale has detected the fault and we've actually failed over. Is that correct?
Yeah, so it took roughly, I would say, about 5 or so seconds to detect that that service was down, and then it went and it moved the workload over. It took, anywhere. It can take, a minute, 2 minutes. It all depends on the size of the database in terms of how
Absolutely.
long it takes for it to fail it over. But the important factor here is that this was something that was happening within the confines of that virtual machine.
Yes.
Again, this example was of the Piedmont service, but it could be, like we said, any number of different things could contribute to it.
Thanks so much for watching, guys. We really appreciate it. We have several other videos we're going to be doing in the series, so feel free to check those out.
Bye-bye.